what it's doing. It's saving the return value of the first invocation of fib. Is that okay? Mm-hmm. So the second one is same problem, right?
Same problem.
Okay, so we just say subtract long $2 from ESP, just like that. Okay, easy enough. We call fib, we undo the parameter itself, and then what we are doing here. What am I trying to do here? Okay, if you look at the C code, okay, what the C code is doing is it is adding the return value of the first invocation of fib to the result of the invocation of the result of the second invocation of fib. I have the result of the first invocation of fib already saved on the stack as per this instruction here. So what I'm trying to do is to add what I have saved on the stack to the return value of this particular invocation.
You need to pop.
But in order to do the minimal change, what do I do?
Dereference ESP.
Dereference ESP. Exactly. That would do it. Because ESP at this point will still be pointing at the saved return value of the first invocation of fib. So if I just add that number to EAX, which is the result of the current invocation of fib, then I will have the sum of the results of both invocations of fib in EAX at this point. I still need to add 4 to ESP to pop this out, okay, because it is no longer useful on the stack.
A dereference of ESP is a return value of the first fib.
Yes.
That's tricky.
Yeah, it is.
Tricky.
Well, but if you're tracking what is on the stack, then you will still remember, oh, we still got something on the stack, and it is the return value from the first invocation of fib. Which also means that when you're doing, when you're trying to solve problems like this, it really helps to have a scratch paper, a piece of scratch paper, and then you can just draw on the scratch paper to keep track of, what is on the stack, and just kind of annotate it, so that way you have a graphical representation of how memory is laid out, when you're working on the assignment. Yep.
So like how much? What are you looking at? Like if we do the program and we fix it so it works, but we didn't fix it like that. Like if I put something in EBX or something like that, what kind of grading are you doing with that?
That would probably deserve like no points. Because of this. Okay, let me just finish this sentence, and then I'll explain why, if you turn in a program that is working perfectly, why I will still give you no points for that. Okay, but let me just finish this part and I'll explain that. And then you guys will say, but how come you did not tell us that on day one? Okay, add result of the first fib to the result of the second invocation of fib. Okay. So we'll go ahead and try to finish this program first, which means we have to change it back to use the assembly version.
Make sure we get the.
And then I have to go back to the make file and undo this part. Fib.
Do you care if you got both of them?
Sure.
Did you get all? You didn't change all of the underscore C's. You got the what?
D-line numbers.
Oh.
There you go.
No, that part is fine. That's not an issue. And it's complaining undefined reference to fib.
You didn't have a global statement in the assembly file. Global field.
Ah, very good.
Nice.
Very good. Good observation. Good job. Okay. 2 is working. 3 is working. 5 is working. Okay, so here comes the explanation of why, if you turn in a subroutine that does the job just fine, why I will still not give you any credit. Okay? It's because you can do this. obj-d for disassemble. And then you can disassemble just about anything, including main itself. So let's see what it is going to disassemble it to. Okay, so we got, let's see, where's fib underscore C? There you go.
Wait, could you show us how to do that?
It's all screen captured. It's going to be on YouTube.
Wait, what is that command line?
It's obj dump dash lowercase d and then the executable or object file name. So that's why if you turn in a perfect solution, I still cannot give you full credit.
You know that's going to
I don't understand what you're saying.
Right?
You know that's disassembled. It's kind of messy compared to it's unreadable.
It is readable. You can look at this address here and say, okay, 804.845D, 804.845D is down
Right
here.
there.
So just give it a label name. Or better yet, do it inside GDB. If you do it inside GDB, it will assign temporary, label names, for the labels. So you can just, reverse engineer everything and just give it like, somewhat reasonable names
We're
and.
going to start off with this code. Condense it.
It's not going to help in the exam because in the exam, my instruction sequencers are completely different from what the compiler generates. So you cannot. So there's no. If you line up my code to what the assembly code is to what the compiler generates, you will find that they don't line up at all. Because I choose instructions that are completely different from what the compiler would choose in the same situation. And I can do optimizations that the compiler would not do optimization. If you turn on optimization of the compiler, the compiler will optimize the code differently from my manual optimization. So that means it's not going to work. Yes.
What's register ESI?
Register ESI is the source index register, which is one of the registers that we do not use or I do not introduce in the class. But it's one of the quote-unquote general purpose registers as well.
So if you see us using register ESI,
Yep.
probably.
So does this mean someone has tried this before?
Sorry?
Someone has tried doing this in your class before?
No,
Assignments?
no one has tried it before. You can do it in the assignment, but if you do it in the assignment, I can usually tell that it is coming from the compiler because we never really talked about the test instruction. We don't really use JE, we use JZ, so I can usually tell, you guys have to put in just as much work to make it look like it is your program. Might as well just write your own program. But it is not a bad idea to take a look at the compiler output just to understand, what the output is supposed to be. But in terms of, the final exam, it's not going to be very helpful. Okay? Is that okay so far? In other words, the next homework assignment on Thursday, the one that you're supposed to turn in on Thursday, if I see something like this, using ESI, using all these constants here and whatnot, I would just say, it's machine generated, which means, that person who turned it in did not do it. And if that person did not do it, I will not give the credit to the person who did it, and I'll give GCC the credit. In other words, in the class, I'll just add one new student called GCC, and then GCC will get the points. I think it's perfectly fair. I'm not saying that I'm not giving anyone any points for the work done. I'm just giving the point to the person who actually did the work, which is GCC. I'll just add it. Okay, I should do it right away, just so that we remember this little discussion here. So we go to assign roles.